Hi everyone, I'm Chirag Jain, and in this video I'm going to be teaching you all about the dimensional analysis. Now it may sound like a mouthful, but actually it's not that hard. To understand it better, let's break up the two words and see what they mean individually. Analysis and dimensional. Now what does analysis mean? Analysis is a study of a certain object or a comparison of two objects. So in this case, it is the study and comparison of the two sides of an equation. Now, in physics, we have lots and lots of equations and formulas to find out different physical quantities. And we use the dimensional analysis to actually find out whether these formulas are actually correct and feasible. Now let's come to the dimensional part. It sounds like a tricky word, but actually, excuse me, it's just anything to do with a dimension. Now what is a dimension, you might ask? It is not like the 2D or 3D movies we see in the cinemas, but rather they are the dimension of the physical quantities in our world. So what are physical quantities? Physical quantities are basically anything that can be measured. So let us take mass for instance. You can say that this bob weighs 1 kilo and this bob weighs 2 kilos. You can measure how much mass is there inside these two objects. Or let's take length for example. You can measure how long this line AB is, line segment AB is in the dimension of length. So what the dimension actually is the measurable extent of a physical quantity. How far you can measure a certain physical quantity is a dimension. So when we measure this line AB, we measure it in the dimension of length. Or when we measure the mass of these two bobs, we measure it in the dimension of mass. But then you might be wondering, what's this kilogram now? What's this kg, or what's the centimeters, or what's the feet? Well, these are nothing but units. And we use units to express this certain physical quantity. Like we can't say that that bob has a mass of 1 centimeter. No, centimeter represents length. It is a unit which is used to express the dimension of length. So a dimensional is anything to do with dimensions. Dimension of physical quantities. Physical quantities. And we use units to express the physical quantities. Physical quantities. So now that you know what dimensional means and what analysis means, let's join them together and make dimensional analysis. It's actually nothing but the comparison of the dimensions on the left hand side of the equation and the right hand side of the equation. And if the two dimensions are the same on both sides of the equation, then it is a feasible equation. So left and right hand side of the equation. So let's actually go and understand what the 7 dimensions are. There's 7 fundamental dimensions, rather I should say, and these fundamental dimensions can't be broken up any further. You can't express them in the form of another dimension. Whoops. So the dimensions, the 7 fundamental dimensions are mass, length, time, current as in current electricity, luminous intensity, how hard an object shines, temperature, and amount of a substance. And amount of a substance just means how many moles it has in it, and moles is nothing but the number of fundamental particles in a substance, like molecules, atoms, ions, etc. So whenever we express a dimension, we always use square brackets. So if we have mass, this is mass, but this is the dimension of mass. This is the dimension of length, dimension of time, current, luminous intensity, temperature, and amount of a substance. So these are the 7 fundamental dimensions which we use in a dimensional analysis. But the best way to actually learn a dimensional analysis is an example. Now in one of my previous videos based on terminal velocity, we used this formula V is equal to U plus AT. I'm going to use the left hand side as green and the right hand side is blue. So let's check whether this formula is actually feasible or not using a dimensional analysis. Now what is V? V is nothing but a velocity, and velocity is displacement over time, and displacement will fall in the dimension of length because you measure how far it goes. So we do L, and always remember it is necessary to mention the powers in a dimensional analysis. For example, if you have acceleration, as we will see a bit later, you will have t square. You won't have t. So the velocity is equal to the dimension of length by the dimension of time. So as you can see, this by this is the velocity. Now let's have a look at the dimensions of the other side of the equation. I'm going to erase this. Let's just keep the list of dimensions over here. Now u plus at is equal to, now what's the dimension of u? U is nothing but the initial velocity. So u will also be the dimension of L by the dimension of time. Don't forget the square brackets. Plus dimension of acceleration is L to the power 1. So whenever we say dimension of acceleration, we can always use the units and try and figure out what dimension it has. Like acceleration is meter per second square. So meter will fall in the length and second will fall in the time. So yeah, L by t square. And I'm just going to write the into the dimension of time over here. So as you can see, this dimension of time and this dimension of time can be cancelled, and we can change this power to 1 using simple mathematics, and we'll actually find that we'll get the dimension of this side as 2L1 by T1, T to the power 1, sorry. And whenever we're doing a dimensional analysis, we usually ignore the constants and we look at only the dimensions. Now as you can see, L to the power 1 by T to the power is exactly the same as the left hand side of the equation. So hence we can prove that this formula is actually feasible. We can actually use this formula, it's correct. So that's what a dimensional analysis is. We basically compare the two sides of an equation and check whether the equation is feasible or not. I hope you understood what a dimensional analysis is, and I hope you enjoyed this video. Thank you for watching.